Okay, so in this lesson, we're going to look at evaluating piecewise defined functions. And so most of you probably don't know what piecewise defined functions are. But before we do that, let's review this function here. So in a previous lesson, you graphed a linear function. Remember, the graph of a linear function is a line. And what I want you to remember about this function is that if you look at this function, the domain is all real numbers, right? So as you go from left to right along the x-axis, every real number for x will have a point on the graph. So the domain is all real numbers. Okay, so I'm going to just go ahead and write this down for right now. So the domain is all real numbers, negative infinity to infinity. Now, one of the other things you learned was that you can find function values from the graph if it's given. And so notice this graph is given. So if I asked you to tell me what f of, let's say, 0 is, remember what that means? That means what is the y value? What is the y value when x is 0? So remember, this is x right here. So if you look at your graph, when x is 0, the point of the graph that corresponds to x equals 0 is right here. So that's the point 0, 5. And so f of 0 then would equal 5. Okay? So if you want to find, let's say, f of 3, then again, that means what's the y value when x is 3? So remember, f of x means y. That's the same thing as y. And so you find the point of the graph that corresponds to x equal 3. So x is 3 is here, right? And so here's x equal 3. So the point of the graph that corresponds to it is right here. And so if you label those coordinates, the coordinates would be 3, comma 3. And so my y value is equal to 3. Okay? And so from the graph, you could easily determine these function values. You could also do that from the function itself. So if I asked you again, what's f of 0, then you would go to your function f. So you would say f of 0 equal, and wherever you see the variable x, you'd plug in 0. So you'd say negative 2/3 times 0 plus 5. And so negative 2/3 times 0 is 0, and 0 plus 5 equals 5. And so that's what you got here. And so if you want to find f of, let's say, 3, like we did here, then you go and wherever you see the variable x, you'd substitute 3. And so I get negative 2/3 times 3 plus 5. And the 3's divide out. So I get negative 2 times 1 is negative 2. And negative 2 plus 5 is 3, which is what we said. And so if you want to find, let's say, f of, let's do one more. Let's say you want to find f of, let's say, 6. Okay, f of 6. So again, you go to your function f, and wherever you see the variable x, you substitute 6. And so f of 6 then would be negative 2/3 times 6 plus 5. And so 3 into 3 is 1, 3 into 6 is 2. Now you got to be careful here. That's the negative 2 times 2 is 4. And I'm sorry, negative 4. And negative 4 plus 5 is 1. All right, so f of 6 is 1. So if you look at this, if you extended this further, notice that this arrow, when x is 6, my y value is 1. All right, so that would be 6, 1, which is what this is. So given the graph, you can find function values. Given the equation, you can find function values. One other thing I want to mention about this line is the difference between what we mean by continuous versus discontinuous. All right, so I want you to notice that if I take my pencil or my pen and I go along the graph, notice that this graph is said to be continuous. So I'm gonna write the word continuous. So f of x is a continuous function. Continuous function. All right, so what that means is basically this. If you trace over it, there's no lifting your pencil point, there's no jumping, you're just tracing over. See, there's no holes, there's no gaps in the graph, no gaps at all. You see that? So every real number, from here all along the domain, so all along the domain, every real number for x will have a y value. All right, and so there's no jumps, there's no gaps, there's nothing. Notice I'm just tracing over this graph. Okay, I'm not lifting my pencil at all. So that's what we mean by continuous. So if we look at the other graph, this one here, this is continuous as well. So if I start here from left to right, if I go from left to right, notice I'm not lifting my point at all. I'm just tracing the graph. You see that? I'm tracing the graph. I'm not lifting my point at all. So that's continuous. So this is a continuous function. So in this case, f of x here, so f of x is continuous. All right. Now let me mention what would not be continuous. So this is discontinuous. So watch. When I go from left to right, see right here, I'm tracing a graph. I'm tracing it. See that? All of a sudden, though, I've got to lift my pencil point. So I'm lifting it, right? There's a gap. I'm lifting it. And then I got to go to the other part of the graph. See, there's two parts of the graph here. So there's this part here, and then there's this part here. So this function, h of x, is discontinuous. So h of x is a discontinuous function. Okay, so that's what we mean by continuous versus discontinuous. And so discontinuous means that if I trace over the graph at some point, in this case, at some point, I have to lift my pencil, then go to the next part of the graph and continue on. Okay? All right, so that's what we mean by discontinuous. There's a gap, there's a hole in the graph, things like that. See, there's a hole even here. All right, so that would make it discontinuous. All right, so for us, though, you're going to see the gaps, though. So for us, you're going to have those gaps. I'm putting a little word here, gap. So there's a gap in the graph. So you have this, then there's a break, gap, break, something like that. If you want to remember it like that, you can. Discontinuous. It's continuous to this point, then all of a sudden this function is discontinuous because of this gap, this break in the graph. Okay? Continuous, discontinuous. All right, so make sure you understand the difference between what a graph looks like if it's continuous versus discontinuous. Notice the break. There are two pieces of a graph that are not connected at all. All right? Okay, now let's talk about this for a moment. Real quick, here's the graph of this function right here. So the graph of f of x is this. So if I asked you to find, let's say, f of, let's say 2, if I should find f of 2 from the graph, then remember that means what's the y value when x is 2. So when x is 2, the point of the graph that corresponds to that is here. And so that becomes 2, 3. So f of 2 would then be 3. All right, so that's the y value. The y value is 3 when x is 2. I could also go here and do that, couldn't I? So if I want to find f of 2, then I'd just substitute into the function. So f of 2 then would be the absolute value of 2 plus 2 minus 1. 2 plus 2 is 4. And so I get the absolute value of 4 minus 1. And so the absolute value of 4 is 4. 4 minus 1 is 3. Okay? If I want to find, let's say, f of negative 4 from the graph, so remember what this means, what's the y value? What's the y value when x is negative 4? So when x is negative 4, the point that corresponds to it is here. So that's negative 4, 1, right? So my y value when x is negative 4 is 1. I could also go here and do that. I could go here. So f of negative 4 would be the absolute value of negative 4. Wherever we see the variable x, I substitute negative 4. Negative 4 plus 2 minus 1. Negative 4 plus 2 is a negative 2. So that becomes the absolute value of negative 2 minus 1. Now you got to remember the absolute value of a negative 2 is a positive 2. And 2 minus 1 is 1. And that's what we said it was. All right. Okay, so that is, this is a quick review in terms of finding function values from the graph or finding function values from the function, from the equation itself. All right, now I want you to notice, though, that the domain of this function, this right here, the domain is, if you go from the graph, The domain is from negative infinity all the way to infinity. So the domain here will be negative infinity to infinity. Remember, for infinity, negative infinity, we always use parentheses. Okay? All right, now let's talk about what we mean by piecewise function. So in the word piecewise function, and sometimes it'll be referred to as piecewise-defined functions, but in the word piecewise is the word piece. And so if you look at this function that we looked at earlier, see this function h of x is made up of two pieces, two parts of a graph. And these parts here, these parts corresponds to these equations. So h of x, let me tell you how you read this. H of x is equal to x plus 4 if x is less than 2. And then h of x is equal to x minus 3 if x is greater than or equal to 2. Now remember, the domain is a set of x coordinates. So the domain for this part here, is this. So this right here, and just kind of say, would be the domain. All right, the domain. All right, so the domain for x plus 4 will be any real number less than 2, and the domain for x minus 3 would be any number greater than or equal to 2. Okay? All right, now what I want to do here is just quickly kind of find function values, and then we'll go here and talk about them. So if I asked you, without looking at this at all, with just knowing this, if I asked you find, and let me go ahead and do it on this one, since I don't want to have all those grid lines kind of interfere with your view. So this is going to be h of x, and h of x is this function here, and here's the graph of it. So if I want to find from the graph, use the graph. Okay, use the graph, so that's this. If I want to find h of, let's say, 5, h of 5. So remember what that means. That means, remember what this means. This means what's the y value when x is 5. So when x is 5, here's my point, right? So when x is 5, that y value is 2. So h of 5 is 2. Okay? So that's let's say this was A. B, let's say you want to find h of 0. H of 0. So h of 0 means what's the y value when x is 0. So here's where x is 0 right here. And so if I look at the point that corresponds to that, that's this. So that's 0, 4. So my y value is 4. So h of 0 is 4. If I want to find C, let's say I want to find h of 4. Let's say I want to find h of 4. Well, again, so what's the y value? What's the y value when h is 4? Well, when h is 4, on the point of the graph that corresponds to x equal 4 would be 4, 1. So the y value when x is 4 is 1. So that means h of 4 then is equal to 1. D, let's say we want to find h of negative 2. H of negative 2. So I go to the graph. So here's, remember, what's the y value when x is negative 2? So when x is negative 2, see that's negative 2 on the x-axis. I look at the graph. I look at the point of the graph that corresponds to that. That's this right here. So that's negative 2, and my y value is a positive 2, right? So h of negative 2 is a positive 2. All right, now here's the kind of new one for you. Let's say I wanted you to find E. And let's say I want you to find h of positive 2. All right, now here's the part that gets students. So h of 2. So when they look at h equal 2 right here, I'm sorry, x equal 2 right here, and they look at the graph, well, there's a open circle here, there's a closed circle here, right? So what that means, though, remember, the closed circle is part of the graph. The open circle is not. So that's not part of the graph. So you must always use the closed circle. So if I want to find h of 2, I'm going to go ahead and kind of write it out. If you're going to find h of 2, you have to use the closed circle. Closed circle. So you have to use that point that corresponds to the closed circle. So So it's going to be this one here. So that point here will be 2 comma negative 1. So again, what's the y value when x is 2? Well, the y value when x is 2 is negative 1. Don't use this one. That's an open circle. Don't use the open circle. Don't use open circle. Because remember, that's not, don't use open circle. So don't use the open circle because remember, that's not part of the graph. Not part, let me put it this way, not part of the domain or the graph, okay, in terms of that domain. All right. Now, what I want to do, now remember, we found this using this graph. What I want to do now is do the same problems, but use the function instead. All right, so this is where you got to listen now. So this is our objective. So the objective for this lesson is to evaluate piecewise defined functions given the function. All right, so notice piecewise, in the word piecewise is the word piece. So notice that this function h of x is written as 2 pieces, 2 parts, and so on. Okay, 1, 2. So 2 pieces. All right. Now let's talk about this using the function. So I'm going to go ahead and rewrite this over. So h of x is equal to x plus 4 if x is less than 2, and then x minus 3 if x is greater than or equal to 2. All right, so listen carefully now as we go through this. You are no longer, for these problems you're now going to see, we're no longer going to be looking at the graph. We're going to be looking at the function instead. All right, so remember when we looked at this one here, and I said using this function, what would be f of 0? So wherever we saw the variable x, you substitute 0, right? Now that one wasn't difficult because there was only one thing to look at. But now you have 2 things to look at. So you have to make sure that you are using the correct part, the correct piece. And this domain here tells you which part to use. So let's look at part A. Suppose you want to find h of, remember it was h of 5, so h of 5. So remember x is 5. So you got to figure out, well which of these, x is less than 2 or x is greater than or equal to 2, is 5 located? Well, 5 is located in this one, right? Because 5 is greater than or equal to 2. So 5 is in this part of the domain. So 5 is in this part of the domain. So you got to use this function. So cover up, if you need to, cover up the rest of this and just look at this one. So h of 5 then would equal 5 minus 3, which is 2. So h of 5 is equal to 2. And that's what we saw here. Okay? So remember, you got to look at your domain. So this is the domain for each of your pieces here. So in part B, let's say in part B, you want to find h of 0. So first of all, you got to figure out, well, which of these I'm going to use? Am I going to use x plus 4? Or am I going to use x minus 3? Well, h of 0, remember, x is 0, so that's going to be here. At 0 is less than 2, correct? 0 is not greater than or equal to 2. 0 is less than 2, so you're going to use this one. So where we see the variable x, you're going to substitute 0. So you get 0 plus 4, which equals 4. So h of 0 is equal to 4, which is what we found here from the graph. Remember the graph? From the graph, with h of 0, so when x is 0, my y value is 4. Okay. C, let's say you want to find h of 4. Okay, h of 4. So again, you got to figure out, well, which of these am I going to use? Is 4 less than 2 or is 4 greater than or equal to 2? Well, 4 is greater than or equal to 2, right? So you're going to use this one. So if you need to, cover up the top part then. So you're going to say 4 minus 3, which is equal to 1. So h of 4 is equal to 1. All right. D, let's say you want to find h of negative 2. So you got to figure out, well, which one am I going to use? Is negative 2 less than 2 or is negative 2 greater than or equal to 2? Well, it's less than, so you're going to use this one. So h of negative 2, remember this is your x value, will become negative 2 plus 4. So where we see the variable x, you're going to substitute negative 2, and negative 2 plus 4 is 2. So h of negative 2 is equal to 2. E, now that's the one that we had trouble with. Remember the closed and open circle? So let's talk about h of 2. So remember, remember what this means. This means what's the y value when x is 2? All right, so remember h of x, same thing as y. So here's what you remember. So x is 2. So is 2 less than 2 or is 2 greater than or equal to 2? Well, it's this one because it's equal to 2. 2 is not less than 2. 2 is equal to 2, so it's this one you're going to use. So it'll be this one. So cover up, if you need to, cover up the one you don't need. So h of 2 then will be 2 minus 3, which is negative 1. So h of 2 equals negative 1, which is, oops, I forgot to put it up here, didn't I? So we said here from the graph h of 2 is negative 1. I just forgot to write it. All right, so negative 1. All right, so let's look at some more examples. All right, so let's look at this one. So this is going to be, let's call this one number 1. All right, suppose my function is this. Suppose we have f of x is equal to, remember these are going to be piecewise functions. So h of x is equal to 3x minus 1 if x is greater than 5, and then x plus 4 if x is less than or equal to 5. All right, so remember, you have piecewise functions, so you have this function is made up of two parts here, two pieces. So if you want to find, let's say a, and let's say we want to find f of 6. All right, so let's think about what that means. So I got to determine which one will I use. Will I use the first one or the second one? Well, that depends on your domain. So this says that I'm going to use 3x minus 1 if the x value is greater than 5. This says I'll use x plus 4 if the x value is less than or equal to 5. So the question is 6 greater than 5 or is 6 less than or equal to 5? Well, it's greater than 5, so you're going to use this one. So again, if you have to cover up your function you're not using, then do that. So that's 3x minus 1. So in place of x, you're going to substitute 6. So this becomes 3 times 6 minus 1. So that's 18 minus 1, which is 17. So f of 6 equals 17. Okay? So that means that if you were to graph this, and you will at some point, if you were to graph this, then that means that when x is 6, my y value is 17. All right, let's get B. Suppose in B you want to find f of negative 3. So again, you got to determine which one you're going to use. You can't use both. You have to use one of them, and that depends on your domain. So when x is negative 3, is negative 3 greater than 5, or is negative 3 less than or equal to 5? Well, it's going to be this one. So I'm going to use this function then. So it'll be negative 3 plus 4, which is 1. So f of negative 3 is equal to 1. C, let's suppose you want to find f of 5. F of 5. All right, so again, you can only use one of these. You cannot use both. You have to use only one. All right, so you got to determine which one I'm going to use. Is 5, remember x is 5 here, so is 5 greater than 5 or is 5 less than or equal to 5? Well, 5 is less than or equal to 5, right? 5 is not greater than 5. You got to use the one with the equal sign. So then I'm going to use this function here instead. So that becomes 5 plus 4, which is 9. So f of 5 is equal to 9. Okay? All right, so that's number 1. So and you could do a bunch more problems like that, but that is number 1. All right, let's go to number 2. Number 2, let's suppose we had this function, g of x is equal to 5 minus 2x if negative 1 is less than or equal to x is less than or equal to 6. And then the other piece is x squared plus 2 if 6 is less than x is less than or equal to 9. All right. So notice that your domain here looks a little bit different than this one, right? That's okay, as long as you're able to understand which one you're going to use. So am I going to use the first one or the second one when evaluating these functions? So let's get to part A. So part A, let's suppose you want to find f of, let's say, 0. F of 0. I'm sorry, this is function g, sorry. So g of 0. G of 0. So you got to find out, remember x is 0, so you got to find out, is 0 in this domain or 0 in this domain? This part of the domain or this one? Well, is 0 between negative 1 and 6? Yes. 0 is less than or equal to 6, and 0 is greater than or equal to negative 1, right? 0 is not between 6 and 9. So it'll be this one. So you're going to use this function here. So this will become 5 minus 2 times 0. So that's 5 minus 0, which is 0. I'm sorry, which is 5. So g of 0 is equal to 5. B, let's suppose you want to find g of 6. G of 6. Well, remember, you got to make sure you use the right one. You can only use one. So this says x is 6. So notice there are two 6's here, so don't get confused. You got to make sure you use the right one. So you may say, well, is it this one? Is it the second one? No, it's not, because if you put 6 here, okay, if you put 6 here, listen carefully. If you put 6 here, 6 is less than or equal to 9, but the problem is this: 6 is not less than 6. It's the one with the equal sign. All right, so if you put 6 here, 6 is less than or equal to 6. That's true. And at the same time, -1 is less than or equal to 6. So that's the one you're going to use. So always make sure you use the right function. So you're going to use this one. So g of 6 then will be 5 minus 2 times 6. So that's 5 minus 12, which is a -7. All right, so g of 6 equals a -7. Let's look at C. Suppose in C, I want to find g of 9. G of 9. Well, I got to use the right one, right? I got to use either the first one or the second one, and depending on my x value here will tell me which one to use. So x is 9. So obviously 9 is not less than or equal to 6. So it's this one. So 9 is less than or equal to 9, and 6 is less than 9. So it's this one you're going to use. So this becomes 9 squared plus 2. 9 squared is 81. 81 plus 2 is 83. So g of 9 equals 83. Okay, so that's number 2. So it's not a very difficult concept. It's fairly easy to deal with evaluating functions. Okay, let's look at number 3. Number 3, let's suppose we had this. For number 3, let's suppose we had h of x is equal to 2x if x does not equal 3, 7 if x does equal 3. All right, so notice this one's different. So notice in the previous two we did, if you look at domain, you had inequality symbols in both of those. See that? Greater than, less than, equal to. Now here you had this compound inequality, less than, equal to, less than, equal to, less than, equal to. Now though, you have this symbol not equal to. Remember, this means not equal to, this means equal to. All right, so listen carefully how we're going to read this. So let's say you want to find A. Let's say you want to find h of 6. Okay, now listen carefully. H of 6. So here's how you're going to read this. So x is 6, right? So the question is 6 not equal to 3 or 6 equal to 3? So which one's the true statement? 6 is not equal to 3 or 6 equals 3? Well, 6 equals 3 is false, right? So it's got to be this one. 6 is not equal to 3. That's a true statement. So that's the one we're going to use. So this becomes 2 times 6, which is 12. H of 6 equals 12. B, let's say you want to find h of -4. Again, same thing. So is -4 not equal to 3 or is -4 equal to 3? Well, -4 is not equal to 3. So again, I have to use this one too. So that'll be 2 times -4, which is -8. So h of -4 equals -8. C, suppose I want to find h of 3. H of 3. All right, now be careful. So remember, h of 3. So this time x is 3. So here's the question. Is 3 not equal to 3 or is 3 equal to 3? Well, 3 equals 3. So that's the one you're going to use. Now, here's where students get a little confused. They don't see a variable here. That's okay. That means h of 3 is going to equal this constant. That's a constant, right? So h of 3 equals 7. So there's your answer. There's no variable. There's nothing to substitute like we did here. So h of 3 equals 7. All right. So that was number 3. Let's go to number 4. Number 4, let's suppose we had k of x is equal to x plus 7 if -6 is less than or equal to x is less than 3. 5 if x equals 3. and negative x plus 6 if x is greater than 3. Let's suppose we had that. Okay? Okay, now, so notice this time I have 3 pieces. So in one of the lessons, when you graph these piecewise functions, it is possible for you to have 3 parts of a graph instead of just 2 parts of a graph. Okay, so you can have, let me go back, instead of 2 pieces here, the corresponds to these 2 pieces, so you could have 3. But I'm not interested in graphing this right now. In this part of our lesson, in this part of our study, we just want to know how to evaluate these piecewise functions. So let's say in part A, you want to find k of, and let's say you want to find k of 1. Okay, k of 1. So you got to figure out when x is 1, where's 1 located? So let's think about this right here. Is 1 greater than 3? No. Is 1 equal to 3? No. But is 1 less than 3? And is negative 6 less than or equal to 1? Yes. So that's the one you're going to use. So you're going to use the top equation. So this becomes, remember x is 1, so it becomes 1 plus 7, which is 8. So k of 1 is equal to 8. B, let's suppose you want to find k of negative 3. K of negative 3. Well, you got to figure out which one you're going to use. Is negative 3 in this part of the domain? Is it here or is it here? Well, it's here, right? Because negative 3 is less than 3 and negative 6 is less than or equal to negative 3. So it's here. So again, we're going to use this equation. We're going to use the top equation. So that becomes negative 3 plus 7, which is 4. So k of negative 3 is equal to 4. C, suppose you want to find k of 3. All right, k of 3. All right, now you see there's a bunch of 3's, right? But you got to make sure it's the right one. So x is 3. So if you make x 3, is 3 less than 3? Is 3 equal to 3? Or is 3 greater than 3? 3 equals 3. So that's the one you're going to use. So k of 3, then you're going to use this piece. But notice there's no variable here, so that's a constant. So that means that when x is 3, k of 3, your y value will be 5. So that's just 5. So k of 3 is 5. Let's say D, let's say you want to find k of 7. K of 7. So again, you got to determine which one you're going to use. Is 7, remember x is 7, right? So is 7 less than 3? No, that's a false statement. Is 7 equals to 3? Nope, that's a false statement. Is 7 greater than 3? Yes, so that's the one you're going to use. So k of 7 then will be, so wherever you see the variable x, you substitute 7. So remember, this means the opposite of x. So the opposite of 7. So this becomes negative 7 plus 6, which is negative 1. So k of 7 then equals negative 1. All right, so that's number 4. Okay, let's do number 5. Number 5, let's suppose we had this. We had m of x is equal to the absolute value of 5x if negative 3 is less than or equal to x is less than 0. X cubed if x is greater than or equal to 0. Okay? So let's say you want to find m of negative 1. M of negative 1. So you got to determine where's this negative 1 located. Is negative 1 in this domain or is it in this one? Well, you know it's not in this one, right? Because negative 1 is not greater than or equal to 0. So it has to be in this one. So is negative 1 less than 0? Yes. Is negative 3 less than or equal to negative 1? Yes. So this is one you're going to use. Now be careful. Remember, this is absolute value. So this will be absolute value of 5 times negative 1, just like this. 5 times negative 1 is negative 5. Just like this. Don't forget, you still need the absolute value bars. But you have to remember the absolute value of a negative 5 is a positive 5. And so therefore, m of negative 1 equals a positive 5. Okay, B, suppose you want to find m of, let's say, 0. M of 0. All right, so you got to make sure you're using the right one. So m of 0, remember x is 0. So if x is 0, is 0 less than 0 or 0 greater than or equal to 0? Well, 0 is greater than or equal to 0 because of the equal sign. So you got to use this one. So this becomes, remember, x is 0. So this becomes 0 cubed, which is 0. So m of 0 equals 0. C, let's suppose you want to find m of 4. M of 4. Well, again, you got to make sure you use the right one. You can't use both. You got to determine, do I use the top equation or use the bottom equation? So x is 4. So here's the question. If x is 4, if you put a 4 here in place of x, is that a true statement? Is 4 less than 0? No. That's a false statement. But if you put it here, is 4 greater than or equal to 0? Yes. So that's when you're going to use. You're going to use this one here. So this becomes 4 cubed, and 4 times 4 times 4 is 64. So m of 4 equals 64. Okay? All right, number 6. Suppose number 6, we had this, f of x is equal to x minus 3 squared if 2 is less than or equal to x is less than 4, and then negative 4x plus 6 if 4 is less than or equal to x is less than or equal to 8. All right, so that's your function f is made up of these two parts, and this part has this domain and this part has this domain. So let's say we want to find a. Let's say in a you want to find f of, and let's say you want to find f of 6. So we got to determine which way to use. When x is 6 in this domain or is it 6 in this part of the domain? Well, 6 is in here, right? Because 6 is less than equal to 8, and 4 is less than equal to 6. It can be here. If you put 6 here, 6 is not less than 4. Okay? So it's got to be this one. So where we see the variable x, you can substitute 6. So this becomes negative 4 times 6. Negative 4 times 6 plus 6. So that's negative 24 plus 6, right? Which is a negative 18. So f of 6 equals negative 18. All right, B, suppose you want to find f of, let's say you want to find f of 4. Okay, f of 4. Well, you got to make sure you use the right one, right? So f of 4 knows there are 4 listed twice. You're going to use one, so you can use one with the equal sign. Because if you put 4 here, 4 is not less than 4. So that's a false statement. So it's here. If you put the 4 here, 4 is less than or equal to 8. That's true. And at the same time, 4 is less than or equal to 4. So you can use this one. So f of 4 then would be negative 4 times 4 plus 6. So that's negative 16 plus 6, which is negative 10. So f of 4 equals negative 10. And then C, let's suppose you want to find f of 2. So you got to use the right one now. So f of 2 is not going to be here because 2 is not less than or equal to 8. And 4 is not less than or equal, I'm sorry, let me rephrase that. 2 is less than or equal to 8. That's true, right? But the false part's here. 4 is not less than or equal to 2. So let's look at this one. Is 2 less than 4? Yes. Is 2 less than or equal to 2? Yep. So that's the one you're going to use right here. So you're going to have 2 minus 3 squared. 2 minus 3 is a negative 1. And a negative 1 times itself is a positive 1. So f of 2 equals 1. All right, so that's number 6. Let's look at number 7. Number 7. So number 7, we have this. We have g of x is equal to 6 if x is greater than 0, negative 6 if x is less than 0. Okay? All right, so let's suppose you want to find, let's say A, you want to find g of 8. G of 8. So again, you can't use both of these, and notice also that none of these have variables in it. See, these are constants. These are constants. See here in number 6, both parts had variables in it, so those are variable expressions. In number 4, if you go back to number 4, this is a variable expression, this is a constant because there's no x, and this is a variable expression. So what we have here in number 7 is we have g of x is made up of this constant is this constant for this domain and this constant for this one. So g of 8, you got to figure out if x is 8, which one do I use? Well, it's going to be this one because 8 is greater than 0. So g of 8 is just 6. B, g of, let's say, negative 4. So x is negative 4. Which one do I use? Well, it's going to be this one because negative 4 is less than 0. So g of negative 4 is negative 6. C, g of 3 halves. G of 3 halves. Well, 3 halves means 1.5, right? Is equal to 1.5. Well, 1.5, 3 halves is greater than 0, so it'll be this one. So g of 3 halves is 6. Okay? All right. Number 8, suppose we had h of x is equal to the absolute value of x if negative 3 is less than or equal to x is less than 0, and then the square root of x if x is greater than or equal to 0. So let's say you want to find h of negative 1. H of negative 1. So you got to determine which one you're going to use. You know you're not going to use this one because this negative 1 greater than or equal to 0? No. So it's this one because negative 1 is less than 0 and negative 3 is less than or equal to negative 1. So we're going to use the absolute value of x. So this becomes the absolute value of negative 1, and the absolute value of negative 1 is positive 1. So h of negative 1 is equal to positive 1. B, suppose you want to find h of, let's say, 0. H of 0. So again, you have zeros listed twice, so you got to make sure you use the right one. So you know it's not going to be this one, because if you let x be 0, 0 is not less than 0. But 0 is greater than or equal to 0. The equal sign is what makes it part of this one. So this becomes the square root of 0, which is a 0. So h of 0 is equal to 0. Let's say in C, you want to find h of, let's say, 9. Well, again, you got to determine what you're going to use. Am I going to use the first or the second one? Well, that depends on your domain. Well, x is 9, so it has to be this one, because 9 is greater than or equal to 0. So that'll be the square root of x. Remember, x is 9, so it'll be the square root of 9. Simplify that, so that's just 3. So h of 9 equals 3. Okay? All right, let's do one more. Number 9. Let's suppose that k of x is equal to, and we're going to have 3 parts here. First one is 4x plus 5 if x is less than or equal to 0. The other one is 3 minus 5x if 0 is less than x is less than 5. And then x if x is greater than or equal to 5. Okay? So this function k of x has 3 parts, and each part will depend on the domain. So in part A, let's suppose you want to find, in part A, you want to find k of, let's say, 4. So you got to determine where's 4 located, which part of the domain is 4 going to be. Well, if x is 4, you know it's not going to be here because 4 is not less than or equal to 0. You know it's not going to be here either because 4 is not greater than or equal to 5. So it must be here. Is 4 less than 5? Yes. Is 0 less than 4? Yes. So you can use this function here. So k of 4 then, where we see the variable x, you're going to substitute 4. So it becomes 3 minus 5 times 4. So that'll be 3 minus 20, which is a negative 17. So k of 4 equals a negative 17. All right, B. Let's suppose in part B, you want to find k of, let's say, 5. Well, notice I have 5 listed twice, right? So I got to make sure I use the right one. So x is 5. You know it's not going to be this one because there's no equal sign. 5 is not less than 5. But 5 is greater than or equal to 5. So that's the one you're going to use right here. So k of 5, where we see the variable x, you substitute 5. So it's just 5. K of 5 equals 5. C, what if you had k of, let's say, 8? Well, same thing, right? You're going to use this one because 8 is greater than or equal to 5. So k of 8, if x is 8, where we see the variable x, you substitute 8. So k of 8 equals 8. D, let's say you want to find k of 0. K of 0. Well, again, I have 0 listed twice for x. You got to make sure you use the right one. Okay, so x equals 0. That's what that says. So is it going to be this one? 0 is less than 5. That's true. But is 0 less than 0? No. It has to be this one. 0 is less than or equal to 0 because of the equal sign. So you use this function here. So you're going to have 4 times 0 plus 5. So that's 4 times 0 is 0. 0 plus 5 equals 5. So k of 0 equals 5. And then let's do one more, e. Let's say you want to find k of negative 3. K of negative 3. You got to make sure you use the right one, right? So is it the first one, second one, third one? Well, you know it's not going to be the third one, because if x is negative 3, is negative 3 greater than or equal to 5? No. It's not going to be this one, because is 0 less than negative 3? No. It has to be this one. Is negative 3 less than 0? Less than or equal to 0? Yes. So we see the variable x in the top equation, you're going to substitute negative 3. So this becomes 4 times negative 3 plus 5. 4 times negative 3 is a negative 12. And negative 12 plus 5 will give us a negative, what's that, 7? So k of negative 3 equals a negative 7. Okay? All right, so that's how you evaluate. That's going to be how you're going to evaluate these piecewise functions. So it's not a very difficult concept. It's fairly easy to understand. Just all it is, though, is a matter of you determining which part do I use, and that part you use depends on your domain based on this x value. Okay, so that's going to be the lesson on evaluating piecewise defined functions.